Hi, I'm Frank Lamb. Welcome to this webinar from the 11th of June 2021. The topic of discussion was systems integration, and I am in a plant, American Beverage Depot down in Miami, talking about some of the projects that I'm working on. Hope you enjoy it. Today's presentation is it's an open webinar for systems integrators, and I am in Miami, Florida, which for those of you who are outside of the country, this is a really hot place. Miami is very humid and hot. Right now it's about 90 degrees Fahrenheit, and it feels more like 100 degrees Fahrenheit. It's very wet outside, but I'm in a nice cool office here. So this was a picture that I took down here in Florida a while ago, and I just put it on here kind of for decoration. So what is this webinar? I usually do a little presentation here in the beginning and tell why I started this webinar. I created this document and people download it, and that's what it's named after. It was a document I made back in 2013. And the reason I did this is because the people in my Automation Academy group basically said they were not as interested in PLC programming. They were interested in systems integration and machine building. And so that's what I've kind of changed the focus of my website to, is more of systems integration than PLCs. However, today we are going to be talking quite a bit about PLCs because that's part of what I'm working on. I'm working on a variety of things, and hopefully the information that I have to share will be interesting to people who watch this on YouTube or who are watching it live. But that's what it's going to be about. It's about me sitting around here at American Beverage Depot and working on kind of a variety of things. So what am I up to here at American Beverage Depot? This is a picture of a SCADA system in the control room. It's a picture, again, that I took a long time ago. And this is a picture of the whiteboard that was in this office when Juan Pablo, who is the owner of this plant, and I sat down to discuss what we were doing on this SCADA system. So you can see here, there are some tanks up here on this whiteboard, and we started talking about how are we going to communicate and start collecting data from this plant. And so we migrated from an old system, and that's what you see here on the left. This is an old RSView 32 system from the 1990s era. They built this plant in 2003, but they were still using a lot of technology that was older. So even this juice batching system was originally a Allen Bradley SLC 505, which was not tag based. It was an older system. And so over time, we've converted a lot of things to much more modern equipment. We've changed all the platforms to ControlLogix, and there is still some old GE 9030s and some Siemens, Step 7 stuff. But a lot of the PLCs here, we have either converted to newer systems or he has bought newer systems. So we do have quite a bit of newer stuff here. And we're trying to modernize the rest of the plant, which basically means setting up a giant SCADA system where we can gather a lot of information from the plant. And so I come down here several times a year and usually stay for 2 to 3 weeks. And I'm here for about 2 weeks this time. I've already been here twice this year, and I've been here several times last year working on these systems. So I'm working on a variety of things here. We put some encoders on a couple of palletizers the last time I was here, and we got one of them working, but the other one has some problems. So I'm going to talk a little bit about those problems and a little bit about troubleshooting and debug. Another thing we did is put a servo pump. Actually, Juan Pablo did this, and he put it in the dissoluter room, which I don't know if I have a good picture of the layout of this. I'll show you something later where this is. And then getting some data from 3 VideoJet printers. Now this has its own challenges because the data right now is entirely in the cloud, right? So we don't even know if we can get this data yet. And then of course I'm creating lots more of these ignition screens, and I'm going to show you some of those and whatever else comes up. So let's address these items one by one. So first off, the encoder conversions on the top tier palletizers. So these palletizers look like this from the front. And they are from about 2011 to 2013. There are 3 of these palletizers. And what they were set up to do originally is there were photo eyes that used to count these slots. And actually, they're still running on the photo eyes right now. As they move up and down, you can see these little platforms here. As they move up and down, they count these slots. So everything is done within about an inch, right? And I know some of you guys are on metric. So an inch is about 25 millimeters. So this goes in 25 millimeter steps, and everything moves up and down and slides boxes in and out of this palletizer. That's the way that works. Well, what they had problems with was sometimes it was really hard to line things up exactly. So we put encoders on them. And to do that, obviously, one of the things that you'd have to worry about is we did probably void any manufacturer's warranty that's on here because we are having to change the program. We had to put a high-speed counter card in the processor, and we had to stick these on the motors, right? So there's a little bit of mechanical to that, and they have the capability of doing that here. So I didn't have to do that. They were able to build this and stick the encoder on the end of the motor, no major problem. But here's some of the problems that we had. So I'm going to slide this off here, and I'm going to show you a little bit of how I work in this plant. So first off, this is a virtual machine, and from this virtual machine, I can connect to many, many things within this plant. There's a lot of programs here, and so right now, just for setup, I went ahead and I'm online with one of the palletizers here. This is the line 3 palletizer. So there are basically 3 lines in what's called the Tetra Pak area. And this is the palletizer from the middle line. So there's line 2, line 3, and line 4. And what you're seeing here is you are seeing the slot counter, right? So position 10 here is the slot count, and position 20 is the encoder count. So whenever the slot counter moves, you will see the encoder move with it. And you can see over here, there is a slot counter on position 11. This is what's called a row hoist, and and you can see it just moved down again. And so what should happen is these two should follow each other, right? My goal was to get the encoder set up to where it followed the slot counter. And that's basically all that I'm doing here. There is a decent amount to this. If you look at the code, well, I'll look at the code in the other program. I'll show you what it does. The other program, let me see, I'm not online with that. So here's the other program. I've got 4 programs open right now, and this one I'm online with, and I made 2 trends for this. I have the encoder delta, and then I have the encoder's trend itself. Now you can see the problem I have with this other one is this was the last time I ran it. I'm going to run it again here real quick. We'll see what it's doing. And it's the same thing. This machine is not running right now. But the problem we're having, so this is a good troubleshooting exercise, is as you can see, I'm going to stop it. The encoder count and the slot count are very different here. And the reason is, if I go here to the code, you'll see that the raw count for the encoder is minus 48,000 right now. Okay. And it shouldn't do that. These encoders should move the same direction forward and reverse. They move between 0 and 1850. So if I go to the other program and I look at the counts, we'll go ahead and go to the encoders area, and I look at the counts. Right, if I look at the raw count, you can see this one's 1500. Neither of these encoders should ever leave the range 0 to 1800. You can see this one just moved here. So if I look at the trend, you'll see that the encoder moved. Now I scale the encoder, right, to these pulses to match the pulses. So I scale 0 to 1850 to match 0 to about 78 as accurately as I can, right? And then I have a switch in here that I can actually flip from going from the slot counter to the encoders. So back to the picture here, right? The slot counter is hard to maneuver here. That's the slot counter. It's just a photo eye here counting these slots, and this is the encoder. And the idea is to make them match exactly as possible. Well, on one PLC, they match fine, right? On line 3, they match. You can see them matching here. And on line 4, they don't. So when troubleshooting, right, look at that, minus 401. So the actual count is minus 48,000. I have an offset in here that I can actually put in to make them match, but the offset would have to change constantly. So there's a problem with the encoders. I'm accumulating more negative pulses than I am positive pulses. So where would you go from here, right? We have already checked the wiring pretty well. The next step is to start substituting known good parts, right? We've checked the wiring. There's a guy named Umberto here, and Umberto's very good at electronics. And so he was the guy who originally wired it up, and he checked it and couldn't find any problems with the wiring. So the next thing we're doing is substituting the encoder. For those of you who don't know what encoders do, they are a disk, and they have little slots in the disk, and inside of the encoder, there is a photo eye that senses the little slots. And so when it moves in one direction, it counts in one way. And when it moves the other direction, it counts the other way. There are A and B pulses. And if there aren't as many A pulses as there are B pulses, then the counts can get off, right? So that's kind of what this is acting like. It's counting more negative than it is positive, or it's getting extra positive pulses. Now, my guess is that it's not actually accumulating extra pulses, but because I can sit there and watch this, and it never changes when it's not running. So it only changes pulses when it's running. So we're waiting for another encoder, and then Umberto is going to wire the other encoder in. We also have a spare high-speed counter, and we're going to stick that in there also. Now, fortunately, of course, this can run with the slot counter. So that's what it's doing right now. If we need to run that, it runs fine, and we put it on the slot counter. So why can I not move this in here? There we go. Okay, so that's what I'm working on there. So we're waiting for an encoder there, and that was one of the first things I did when I got here. Okay, so that's kind of in passing. I sit at this little desk, or I sit here, and I look at the pulses, and then I can flip it from using the slots to the encoders as we go. The second thing, installing and integrating a servo pump. This is a very unique application here. There is an entire Allen Bradley processor assigned to this. And the reason is they bought this servo pump from another plant somewhere else, maybe in Canada. And he got this pretty inexpensively, right? And normally you would have a pump like this. It's just a VFD, and it runs this motor, and we pump syrup out of a barrel, and you can see kind of a corner of the barrel, but it pumps out of the barrel and into some big tanks. Now, the big tanks, I'm going to see if I can find some pictures of the big tanks. These are some of the SCADA screens that I work on here, and the big tanks that it pumps out of, this is sort of a layout of the plant, are these two. So these are called the dissoluter tanks, and they're in a different room. I actually have some pictures of them I can show a little bit later, but these dissoluter tanks are in a different room, and we pump out of barrels into those tanks. So the way this whole process works is you pump from outside, you pump fructose, right? And fructose goes into the tanks, and then sometimes powders go into the tanks, and then sometimes a juice concentrate from a barrel also goes into the tanks. It's mixed there. And then there's a quality control to make sure that that batch is okay. And then they mix it with water. It's very concentrated at this point. They mix it with water, and they pump it to all of these different tanks here. So you can see this screen capture that I did. Some of these tanks were running. And this screen capture, you can see some of those tanks were running also. These are the 6 tanks that are shown here. Okay, so, and these are the outside fructose tanks. So we pump from fructose to these. We use the the little wand and we reach into the barrel and we pump into these, and you can see there was only one barrel right here. Well, we want to use 2 barrels, and that's why this pump was the one that pumped from 1 barrel, but we want to migrate to being able to do 2 barrels at once, which involves adding a pump, adding the code for the pump, documenting everything, of course, wiring the pump in. That's what you see here. And this goes to another room, right? So the servo card that drives this, to be able to do this, we had to put a whole new processor in here because the drive that this runs on was far too new for the other processor we had. We had an L63, which is an Allen Bradley older processor, and we had to use an L70, which is a newer processor with the newer software to drive this. So we have one PLC rack with 2 different processors in it. The only thing we're really waiting for on this has been tested, but the first time that it was tested, it actually blew some of the seals out. Somebody forgot to put the pin back in all the way. So we ran the motor by itself and then put it in the tank, and somebody forgot to put the pin between the motor and the coupling back in, so it sheared the pin off, which was not good. And they had to wait quite a while, and then they had to rebuild the seals on it. So all that's back in shape. And I have this cool little, this is kind of a neat thing. I don't know if you can see my little picture up here, but this is there we go, a little tablet. And what they did is they gave me this tablet, and we'll see what it does here. Doesn't look like it does anything, but there is an ignition screen on the tablet, and I can actually bring it up. Let me see, sign in. It says dissolution room. And I haven't even really tested this yet, but I would have to, oh, there we go. So the dissolution room is working. Let me see what it does here. So I'm running this remotely, right? This is sitting at my desk, actually in another building. And we'll see what this does. You can see it actually opening the ignition project, right? It's kind of neat. And I can theoretically go online with the processor from this thing by walking up next to the pump and driving it. And we'll see what it brings up. It brings up the entire dissoluter page, which is not what I want. I just want the pump page. Let me see where this even is. Main JP1, maintenance. We'll see what it does here. Like I said, this is actually the first time I have opened this, and I don't even see it here. So it may have the wrong program loaded on it. So this is the kind of thing that I would do, but there is a screen on here that has just run the pump forward and run the pump reverse. And Juan Pablo, who is the owner of the plant, like I said, that's kind of unusual having the owner of the plant actually, the guy who can program and things like that. There are 100 and some odd employees here, and still the owner, who is only in his 30s, is the guy who does a lot of the programming other than me. So I come down here from about 1,000 miles away and work on this stuff. But that's how we're doing this. So there'll be a little touch screen, and I can walk up next to this and run and stop it. But one of the things we're doing is we're going to hang a start and stop button next to these tanks, and he's going to be able to start and stop it from those. So again, I'm waiting for Umberto to wire that in, and hopefully they'll be done with that pretty quick here. So that's the other thing I'm up to that's physical things. The other thing that I'm up to here is this is a video jet coder, and what it does is it puts text on these juice boxes. And I don't see a juice box around here, but it basically prints. You can see this here. This is the print head, and there's a photo eye here. It triggers it and it prints this. Well, because we're picking up data from all over the plant, what we'd like to do is we'd like to pick up a signal saying every time this codes, right? So every time it prints something on here, we want a signal. We have talked to the vendor, and they said, well, all this data is present on the web, right? They have a service contract, And these 3 coders are connected via a little wireless point here to another room, and then connected via Ethernet to the internet, and then it goes to the cloud, and you can access the dashboard. What we're afraid of is that that does not represent actual data as we need it, right? What we need is we want a way to count these. We don't just want to pick up necessarily a count from somebody else, and we definitely don't want to look at a dashboard on the internet. We want to bring the data into our ignition system and count it that way. So we don't know if that's possible yet. So if not, then what we're going to have to do is come out of one of these ports on the side of it and either pick up the Ethernet signal, or they have USB ports and you can pick up something from the USB ports. It would be easy to just pick up a signal from the photo eye and count the boxes, right? But we wouldn't know if they were coded or not. So another way, of course, put a camera after it and trigger it and inspect every time this happens. Right now, they don't even have a way to reject these. So if you had a bad print, they would not even know it until it got to the end of the line. And then you'd look on the pallet and you'd say, hey, these don't have codes on them. And I asked somebody yesterday if that ever happens, and they said, yes, it has. So that's something else to work on. We have many, many things to work on. So what's the other thing I'm working on? Well, this, and this is most of what I'm working on. And I want to spend some time today talking about this project. This project has been going on for years, and it will go on for years and years more. What we want to do is pick up data from all these points here. And I'm going to show you this screen, right, is just something right now. I actually stuck this on here yesterday. I copied it from another screen just to make this screen look full. But I'm going to go ahead and flip over to the actual ignition project now. And I'm going to show what I'm working on there. So you can see here, I have a lot of things open. I'm on the plant server, and all these VMs here are, the VMs are just PLC programs. So one of which I do want to come back to, so I may come back to this, and that is this one, which is one of the projects I'm working on right now connected to ignition. I'm trying to pick this stuff up. So this is an integration themed webinar. So I really want to talk about what it takes to put together a very large multi-year system like this. The first thing I want to kind of mention here is that what is your best friend in systems integration? Vagif, you're the only one on here, and I would say, what would be the best tool that you use for systems integration? And some people might say, oh, ignition, or they might say the PLC programming software, or they might say, I don't know, some other computer tool. And my answer would be, no, it's probably not your best friend there. Your best friend is Microsoft Excel. Okay, so why is Microsoft Excel your best friend? Because there is lots and lots of data that I need to gather from all over the place, and often that data is not in a format that I need, right? And my brain doesn't hold all this information, obviously, and I can do things like I'm doing here. So I'm going to show you my paper, right, trail. I have lots of sheets of paper here, and I'm writing all kinds of things down. I have 9 written pages of stuff, right, since I started here Monday. So when I came here Monday, I wrote some stuff down on page 1, and I'm down here on page 9 so far. But when I write things on paper, right, that's not a good way to present information to other people. So I have to create spreadsheets, and I have lots and lots and lots of spreadsheets. This one, I actually just started creating this morning, and it's already getting pretty full, right? This is just IO from, and I'm going to show you where it's from here. Show you a little different layout. If I go to the ignition screens, and we'll zoom out here. This is this is kind of a collector for, we'll zoom out, for my ignition screen. So we'll zoom in one more and make it a little bigger. So this is a kind of a data map of the plant, right? So all of these points, everything that you see a color on, and a lot of these, some of these things are live. These are actual tank values. I put these in here yesterday and I can already see a problem. Let's see with this one. We'll do a little coding here right as we speak. Here's a little ignition work. All I need to do is back that out, put a space into it, click somewhere else, right? And it changes the format and the way it displays. So I'm kind of working on these things as I go and changing things and making the screen look pretty. But the goal for all of this is to put this on a big screen in the plant, and somebody can look up and they can tell the status of the entire plant as they go. So what does the plant look like here? So this is just a diagram with lots of icons. The actual plant, let's see here, we'll go to Windows, and I'll show you some other screens. I created some maps. PET window, let me see where things are. Syrup window. The syrup system, I think you've already seen a printout of. We'll go to main window. So main navigation. See if that pops up. Syrup, main. Yep, that's not active yet. We'll go here. How about main window? There we go. That's better. So this is an actual physical map of the plant, and it doesn't even include everything on the plant floor. Those 6 tanks you saw are physically here. There's a 7th tank, but we really don't use that tank. So these actually light up when they're active, right? That's the idea. So I put little circles over here so that they turn green when they're active. And the ultimate idea, if I wanted to look at a map of this plant, would be to have icons over everything. So back when I'm looking at this and I just see line state, for instance, let's take the blower. Okay, so this item here, if I go to the main window, is here. It's this. That's the blower, right? And then there's a filler, and then there's a conveyor, right? And here's a wrapper. There's lots of things, palletizers. The 3 palletizers I told you about before are these 3. Let me see. Actually, they're not. They are, we need to update this. So I'm in the process of doing that too. They are here, here, and here. These are the 3 Tetra lines. So they're mostly accurate that you show here. And we kind of show a 4th one here too, but there are actually only 3 Tetras. So I do have a new CAD drawing of the plant, and I'm updating this as we speak here. But the 3 palletizers are at the end of this line. So this is kind of a map of the entire plant. So you can see physically where everything is here. For instance, the little servo area I mentioned before with the pump, that's in the back of this, right? So the 2 dissoluter tanks are here. So this picture is not a geographical picture of everything. But again, if somebody looked up on a big TV screen in the plant and they saw this and they saw something blinking, right? So this is not really, I'm not even connected to the helix, but if they saw everything was all green, let's go here and I can fake all this as we go. I opened up, unfortunately, all of my windows. Let's see, data, state, see it says 5. So to make it a fault, I put a 5 in there. I'm actually going to make this a 99, and that should turn it white. There we go. So I can change any of these. None of these are active yet. So I put all these on here yesterday, and I made an icon that says auto idle, auto run. I'm going to be changing these today to say, instead of auto run and auto idle, I'm going to say filling or producing, or filling or production. So filling means it's coming from these dissoluter tanks and filling, or it's going into these lines. So that'll be more information. So what I did right now, just to kind of create the screen, is I made one of these and I copied it, you know, many, many times. So each one of these things represents for sure a PLC, maybe more than one PLC. Like in some cases, if I come out here, there may be 2 PLCs on the chiller. Really don't know in a lot of cases. So where do I get that information from? From yet another spreadsheet. So, right, this spreadsheet is Ethernet communications as of March, which was the last time I was here. So one of the things that happens is, because Juan Pablo and I are the only people in here working on the technical system, all of these spreadsheets are created by either me or him, and I would say mostly me. He's not a big documenter, right? He creates a lot of ignition screens, but he doesn't create a lot of documentation, even though, right, it is very important to do all this. So this represents, if I look at this plant, look at all the Ethernet addresses that are here. Everything in yellow, I have the potential to connect to. Right? So this is all the internal plant, you know, PLC addresses. And then there's some things like these aren't even like this labeler. This labeler is not even on this master network, but if I walk up to it and I want to connect it to my computer, I can do that, right? If I look at this wrapper, I don't even know. Let me see. Actually, I do know. This one's kind of in process right now. It's not even a PLC. We're migrating it to a ControlLogix, but right now it's a Siemens computer from about 1990. So it's an old computer system connected to some Leroy Summers drives, and there's no way for us to gather data from this at all. But we are, again, this is another project I'm involved with, migrating this to a ControlLogix. Once it's a ControlLogix, we'll have more control over it. We obviously, once again, we void the warranty on something like a wrapper. In one of my previous webinars, I showed this wrapper and we talked pretty much in depth about what we were doing to it, upgrading everything. But that's where all these addresses and things come from. I can see somebody else joined here. That's cool. So these are a lot of the things in the plant. Some of these things here, like the coder. The coder was the thing that I showed you before, and we don't have an address for this because this is the one that we will have to pick information up from the web. So I've got the coder represented in here as, let me see if I can pull this off the screen. I think the key is I need to pull it from this left edge, and there we go. I'm able to pull it off. The coders are these things, and they're actually very tiny if I look at the entire plant, right? So if I go here, right, those coders are right outside of these. You see these 3 things going through the wall, and the coders are a little dot right here. So if I wanted to put the status of those coders, that wouldn't be a very good thing to do on this screen, right? Because it would be really tiny. So for me to look at this screen and see the status of things, the only things I can really see is the status of these tanks, right? So that's not a lot of good on a wall. But the idea behind this, what this is going to become is if I click on, let's say I click on this, what I want to do is I want to go to that machine. I want to bring up a breakout of that machine, and I want to see all of its information. So let me see if I've got anything popped up here. I think I have the PET line in here. Windows. See, there's a lot in these ignition programs. There's a whole lot of screens, main navigation. I think I have the PET line somewhere. And Ignition's a pretty good SCADA program. I used to work a lot with a lot of Alan Bradley stuff, and I've worked with Wonderware and things like that. But Ignition is much more modern. Let's see, there's a PET window, the PET line. We'll see if that pops up. There we go. There's just the PET line. So this was what I was talking about, the blower. So ideally what I'd like to do is if I click on the blower, I would have a screen that was just for the blower. It would basically be the HMI for that blower. The same thing that if they walked out to the machine. So there is a computer right here on that blower. And once again, this is an S7 400 Siemens PLC, and it has its own little computer connected to it. And unfortunately, I cannot import the program off of this into Ignition. The only thing I can do is recreate the screens from here. And these are not, these are actually proprietary screens. This is a Seidel blower with an S7 400 on it, and Seidel owns everything on there. So the only thing I can do is open Seidel's touch screen and either imitate it or create my own screen. So that's kind of why I do things like this, right? This is not a pictorial representation of the things in the plant, but it does show all the status of the things in the plant. And once again, as I mentioned, these are not real. I'm not connected to any of them. The only things I probably, I'm very much connected to these. So these are real time, right? What I'm not connected to yet is almost everything in the middle of these Tetra lines. I'm connected to the palletizers, as I showed before, right? I'm connected to them here, and I can pick up any data from anything that I can go online with. So let's run this again, see if they're running this plant, and no, see, nothing's changed there. So anything that I can see here, I can monitor. So I could monitor this palletizer. I could monitor these positions. I can tell whether it's running. I can tell the positions of everything. I can tell the production. So if I need data, I would go in here and create a counter. As a matter of fact, I did that, and I believe, so most of the code you see here was originally from Top Tier. Top Tier manufactures palletizers. Let's see, we'll show a picture of the palletizer again. They manufacture palletizers that look like, let's see, that look like this, right? That's one of the 3 palletizers. They manufacture those. They give you the program. So that's one of the nice things about Top Tier. They give you a copy of the program, and it's got comments and everything on it. Unfortunately, Seidel does not. As a matter of fact, they protect their programs. So if you want the program, you need to go online with the processor, pull the program out of it, and it will not have any comments. That is a nightmare for Siemens. For Allen Bradley, it's okay if it's a newer processor. The names of the tags are okay. But for Siemens, it's a nightmare because the step 7s, all the 300s and 400s, no names are in the processor. So if I pull the raw code out of there, I have to name everything myself. It's going to have things like db42.dbx16.3. That doesn't mean anything to me, right? I don't have any kind of a table to cross-reference those unless I label it myself. So that brings up the problem that I'm running into right now. So I'm going to get back into a little of this systems integration thing here. So it says whatever else comes up. Here's some of the pictures, by the way. I put these on here, whatever else comes up. Well, one of the things that's come up is picking up data from these other things that I showed on this screen, right? So let's see, I'll pull this up out of here. Picking up data from Ignition, and I'm going to show you what I'm working on today. We're going to segue into that. Looks like we got about another 20 minutes, and I'm going to segue into that. So what I'm working on there is this area, right? So I didn't show this, and the other screen didn't look like this, but there are several compressors. There are cooling towers. There is a giant compressor that I haven't even put in here. It's the high volume compressor that's used to blow bottles. So when I went to that blower, it is the thing that fills the bottles, blows them up. And you have to have, I want to say a 300 horsepower motor, big compressor, very loud. Sounds like a diesel engine when it's running. That's going to go in here too. So for instance, I can just copy these. I'll do this in real time, copy. paste, show you how easy ignition is to run with. And I just say high speed compressor. Let's see. And sometimes I can click on this and it changes. Sometimes it doesn't. And when it doesn't, you have to go down here and edit it. So I'm going to say, I'm just going to call it high pressure and compressor. All right. So I'm working as we speak here. So that way I know what this is. And I'll just, should I put a dot? I think I already did put a dot. Okay. So all I'm doing here, right, is I'm saying, well, there's a high pressure compressor here in addition to these other compressors. Now, for the rest of this webinar, I'm going to show you the problem that I'm having with dealing with this. This will give you an idea of the problems that you have when doing systems integration. So the guy who brought the data in for these is a guy who used to work here. He is from Cuba. Cuba speaks Spanish, okay? I speak English. I speak a little bit of Spanish, un poco, so just a tiny bit. Now I see Burhan, you look like maybe you speak French. Do you speak French? Okay, you have to unmute yourself and I'll be able to hear you. Oh. There we go.
How are you?
How are you?
I'm fine. I'm from Ethiopia. I'm speaking English.
Okay. Demisi almost sounds like a French name. That's why I commented on it. But it's probably an Ethiopian name then, right?
Yes, yes.
Yeah. If I spoke French, I might say Demisi, right? Or something. It might sound like that. Vagif is from somewhere else too. He said his English is not great either. My Spanish is not great. So I have a problem with this particular program, and I'm going to show you what kind of problem I have. So in Ethiopia, you speak English, but you probably speak, I don't know, Ethiopian, right?
Marik.
Marik?
Marik, yeah.
Okay. So different language. So this is an illustration of some of the problems you'll have. So you can see my screen here. So I'm going to show you, first off, I'm going to show you the programs that I got, and I'm going to explain the problems I had. First, I got here and I did not have a copy of the program for the data collection for all these things. So there was a PLC that had a program in it, and it was, if I look at the layout of it, it is, let's see here, this one. So this is the processor. It's a Allen Bradley L63 processor, and it was in slot 0. And so the guy who built this system is an ex-employee here. He was a programmer, and he since left and he went to work for a systems integrator. And then he came back in and he did some work for the plant. This is because I can only come down here maybe 5 or 6 times a year. The distance from where I live to here is probably as far as all the way across Ethiopia. It is 1,000 miles to my house, and that would be about 1,600 kilometers. So I don't know how big Ethiopia is, but that's a long way. It takes me really 2 days to drive it. I can drive it in 1 day. I can drive it in 16 hours. We have very fast highways here, and I can drive it in 16 hours, but it's a long distance, right? So I only come down here 4 or 5 times a year, maybe. And of course I can fly here, but if I fly here, I can't bring a lot of stuff. So when I stay for 2 weeks, I like to bring a lot of things, right? I bring my extra clothes and I bring my guitar. I like to play guitar, so I bring that. So I'm here, and this guy, it lives here, and he can come in and he can work on these systems. So he built this panel, he put it on the wall, and I already had a data collection PLC in another place. And I'm going to show you the data collection PLC. Hopefully it will show up. It does not show up. So I'm actually going to browse for it and try to open that. Actually, the easiest way to do it is probably to just go into the directory So let's see here. So there's a lot of PLCs here. This isn't a, we're working off the server here, and these are all the different PLCs in the plant. Some of them are Siemens. Some of them are, you know, this is a folder that I made because the other guy did not have access to this server. So I had to put all this in here, right? I put the 2 programs you saw in there.
Okay.
So it's kind of my job to keep up with this because, as I said, myself and the owner of the plant are the only 2 people who have access to this server. Well, a lot of people have access to the server, but we're the only ones with access to the PLC part of the server, right? So to the virtual machine, which is what we're running here. So what I did is I have another PLC that used to be in the middle of the plant. It was I don't know, probably 50 feet or 15 meters from the panel that this one is in. So I'm going to open it. Data acquisition, I can actually go online with it. So this was the copy from the other day. And what I did is I took the PLC out of the middle of the plant and I stuck it in this guy's rack. With Allen Bradley, I can have more than one processor in a rack. So this is opening right now, but basically what I did is, and I'll just go back to here. I stuck it in slot 11 or slot 10, maybe slot 10 or 11. And we'll see when it pops up where I stuck it. Let me see. Data act, there it is. Hopefully it's open. There we go. So this is my program. So what I had to do is my processor used to be in slot 0 of the other rack in the middle of the plant. I took it out of that slot and I said, let's get rid of that. Let's bring it over to this processor. Since we weren't using any IO in the other data acquisition, all we were doing with that data concentrator is connecting to other PLCs and bringing information in. That's the only thing it was doing. So I brought it over and I put it in this rack. Now what this allows me to do is I can go to the Alanimus processor, which is this one, and I can read all of its IO. Okay. The problem is I don't know what this IO is connected to. I have no idea. So how do I find out? Well, I look at the documentation from the guy that did the system, right? Here's the problem with that. I mentioned he's Spanish, right? He's not, he's not a English speaker. He speaks a little bit of English, but he's from Cuba. Let's see. So here is, boy, I'm having a hard time finding it. Here we go. I think it's up here. Yeah, this is it. So what I got from him is, well, I'll just bring it from up here. Anyway, I got a folder full of a bunch of things. I got PDFs of the electrical drawings. I tried to open the PDFs, they don't open. Okay, so they're corrupted. There's something wrong with them. No one checked them. So I have no drawings. Okay.
It's hard to create the fault.
Right, right. So I don't have the drawings, but I have the rack and I can figure out from the program what things are connected to. So here's the problem with that. The programs look like this. So if I open a program, first thing I tried to do was I tried to just go online with it, and you can see this one's called Test 1. Test 1 was me going online and uploading the program from the processor. When I do that, I get no comments, right? But I do get all the logic that's the current logic in the processor. Here's the other problem. I don't know if any of you guys do Allen Bradley, but Allen Bradley has many, many versions of firmware. Your software has to match the firmware. So this is a version 20 PLC. Version 20 is a kind of a funny deal. It was in between the old ControlLogix, which was version 8 through version 19 or 20. And then there's new, which is Studio. So Studio is 21 and part of 20 through about 33 right now. This was right on the borderline. And at that time, they had a 20.01 and they had a 20.03. And if you try to open 20.01 with 20.03, it's going to automatically convert it. It will not allow you to go online with it. Well, here's the problem. I have a version 20.01 on my computer, but I can't connect over the network here. I can't use the virtual machines to do that. So the only thing I can do is use this virtual machine, connect to it, and upload. So I have all the current data, right? This was real data from that time, but here's the original program that he gave. Now, there's a couple problems with his program. One, everything's in Spanish, right? This is not English. Funcionamiento, bomba, recirculación, right? At least it says chiller. I understand chiller. I know bomba means pump. Okay, so that's okay. Compresor, right? That's compressor in English. That's pretty easy too. Torre, I had to look that up, but that's tower. So that's the cooling tower out in the back. But these abbreviations, right? These are not, these are the tag names. And these are raw data. The other thing is when I looked in this program, which was the program he saved, this is from October. He finished this in January. So this is 3-4 months earlier than the version that I have. So he didn't finish it. Now I go to the program that I uploaded. No comments, right? So I don't know what this was, but the tag names are still the same and the program is much bigger, right? So I can see what's connected to what. So once again, I think you missed this part of it, Burhan, but when I got here, I mentioned that your best friend as a systems integrator is Microsoft Excel. Trying to bring it in. And I'm going to show you what I've had to do with this. I'm going to have to make it smaller though to fit on this screen. We'll drag it down. So I'm on multiple screens here. So this is, I started this spreadsheet this morning. Okay. And I'm gathering information from the program I uploaded and the program that he left, right? So if he had a description here, then he put it here. But then there's other things that I pick up that don't have descriptions on them. And most of them, I believe, were in the analog area. This, right? There was one description in here, platinum thermocouple. I know what that is, right? This picks up temperature. All these are thermocouples, but there's no names. What I do know is I know what directory they came from. So these are platinum thermocouples on chiller 1. These are platinum thermocouples on chiller 3. These are on compressors in room 2, but there are 2 compressors in room 2. There's compressor 1 and compressor 2. So I don't know which one they are. And I can't open the electrical drawings because the PDFs are corrupted, right? So what I'm going to do is I'm going to pick up these points because they're in my same rack. I can pick those points up raw, right? So let's try going online with the Data ACK PLC, and I should be able to read these. We'll see what the temperatures are right now. So I opened Data ACK, and this is how easy it is to pick up points. See, I got 5 programs open now. Okay, this one. So if I say go online, this is the path. Hopefully it will pick it right up. And we'll see how long it takes to pick it up. Yep, picked it right up. Okay. So I got a lot of PLCs, like I said, on this network, including Siemens PLCs and GE PLCs. There's a bunch of 9030s here. So now if I want to read one of these cards, here is an IF8. So I didn't even know that this IF8 was, let me go up here and see if I can find that spreadsheet again. Oh, there we go. So let's see, slot 5, IF8. We'll go see if we can find it. That's over here. Oh, this is what I imported. So that's another thing. So I imported the tags from his program, and that's where I got all these comments, but you can see that's not complete, right? So slot 5, the only thing I found was 1 point. That's where I got this from. So wrong spreadsheet. So try to find the other one. A lot of spreadsheets open here. IO list. There we go. That's this one. Okay. So this one, slot 5, if I go in here, as a matter of fact, I don't even show slot 5. So there's nothing in the program for slot 5. So they put an IF8 in there, which is I think it's a thermocouple card actually. IF, I believe, is thermocouple, but I'm not sure. I'd have to check. So let's go in here. Here's the IF8. Here's all the other ones. So the points that I picked up, if I want to go look at these values and I want to find out what they're connected to, I can go to the controller tags. I can look at the raw data. Local, anything I added here. Here's 6i. Look at slot 6, and I can look at what's in there. So I browse down. It's probably way down at the bottom of slot 6. There we go. These are temperatures. I don't know what they are temperatures to. So one of the things I always say is the very first thing you should do before anything else, if you're approaching a project like this, is create an Excel spreadsheet. You don't know what you're going to use it for yet, but if there's things that they give you, maybe they give you an Excel spreadsheet. Awesome. Then you can use that as the start. But what will happen is you'll start adding page after page after page. You'll add worksheets and you'll start gathering information. So for instance, on this one, let's go back. I only have one worksheet on here so far. And let's see if I got another good worksheet to show too. No, we'll just do that one. So this one doesn't have any other worksheets, but this is the IO. If, for instance, I wanted Ethernet addresses from this system, right? Because there's a bunch of other things on here. Now I already have another spreadsheet that has Ethernet addresses on it, right? Matter of fact, I'll bring that over too. We looked at that before. So this is my master sheet for the entire plant. And this was kind of what we started out with on this webinar. This I made quite a while ago as just a, what's connected to the system. So I've worked on some of these systems. This was the syrup room when I first started coming here like 6 years ago. I started out working on this system. It's the big system with all the syrup tanks on it. So I had to list, right? I got a bunch of remote nodes here. All of them have IP addresses. I have the processor itself. I have a device net scanner and it's got things on it. So if I wanted the device net, I have another spreadsheet that has device net addresses, but I don't need that here. This is really for me working on the overall data of the system. But all these other things, the palletizers I started out with, they are here, right? And we use a router and then we go into the palletizer and its processor is here and then it talks to all these things. So one of the integration things that I had to deal with just the last time I was here was these addresses are the same, right? And how do you then talk to two different palletizers with the same address in the plant, right? You can't even put them on the same network because they would interfere with each other. So what did we do? We put a router in there and the router has the 218 and 219 address, and that's how we get into this network. There is a third palletizer here. This one is an Allen Bradley 1500, which is the Micrologix family. It's an old family, doesn't even have Ethernet. So how am I going to get this information? I either convert it to something like a 1400, which does have Ethernet, which we have actually done that. As a matter of fact, Juan Pablo, the guy who owns the plant, like I said, I talked to him and he said, yep, we've got a whole processor. I've already done the conversion. Great. It's sitting on a table over here, but I have to make time for somebody to go into that and take all the wires loose from the existing palletizer and connect it into this new one. And it'll probably take easily a week right? To check all the IO, make sure everything's wired correctly. And then how do you go backwards? If it doesn't work right, how do you go back to the old processor when you disconnected all the wires and you reconnected them to the new, and they look a little differently, right? The 1500 was probably this big, you know, and it had digital, you know, digital and analog connections to drives and things like that. The 1400 is a little bit smaller, but he made sure that all the cards matched up and everything like that. So we can switch that out. We can get directly into Ethernet, but you can see here, I've got, like this is probably a Micrologix, right? I don't even have a connection to it yet. If I want a connection to it, I'm going to have to put what's called a net ENI and assign an address to it, or pick it up somehow. You could use Modbus. You could use I don't know, anything just about, right? Some people now are using MQTT, right? They use a produce consumed, you know, subscriber publisher kind of network there. But all of these things have to be approached one at a time. You can't do everything at once. So what am I doing right now? I'm mostly working on these palletizers, but then all of a sudden, maybe I have a little ADHD and I look around and I say, squirrel, right? And so the squirrel for me is this data acquisition thing that is over here. When I looked at his system, here it is.
Okay.
Here's what he's connecting to, right? He has a processor, this one, right? And then he has I even wrote facility data HMI here. That's not what it is. Support L63. So this is Alarmus. This, I had it written down as support L63. It's now going to change to Alarmus because that's what the other guy named it. But
Okay.
you can see the problem that I have is that, like I said, I don't know what his data is. I can connect to it. I can guess what it is. And that's part of what I'm doing here. I am guessing by looking at these temperatures and going out and tracing these and going and seeing where do they connect to. Or I can ask the guy, his name is Joandro, and Joandro could tell me where some of this stuff was. But my biggest criticism of what he did is he did not start a spreadsheet. So there is no documentation of the IO list and what is connected to what. All I can do is guess. And the way I guess is I use my spreadsheet and I look at these temperatures and I say, yep, they are updating in real time. And then I look at his code and I say, yep, that is part of chiller 2. So how much of this do I need? Well, the main thing I need right now is these. The main thing I need is I want to know if it's running or stopped. And since I have room, maybe I'll put some temperatures out here. But the fact is, this is going to be a TV screen on the wall. This is one of the things that the maintenance manager and the plant manager have mentioned, that they would like to be able to look up when in the plant, look up on the wall and see what's running and what's not. And if you see something red and flashing, then the maintenance guy or operator runs over to that and he figures out what's wrong with it, right? So the red is a signal. That's why you make everything, right? That's why you make everything green and red and yellow. And hopefully people aren't colorblind. That's a problem. Sometimes people are colorblind in the plant, but that's why I'm making it flash. And that's why I have a word in it that hopefully read. But the TV screen for this will have to be, I don't know, 6 feet across. The plant is very large. So here's the map again of the plant. That's the plant. So the little palletizers you saw are only about this big, right? The big tanks that we looked at they are only this big. This is an actual CAD drawing of the plant. So it's actually getting close to end time. So I'm going to drag this back across. Right. This was the map of the plant. And I'm going to show you some pictures again of the tanks and things. These are the tanks. So this is a top view of those tanks. There are 6 of them in this room. This is a top view of some of those conveyors in one of the rooms. This is the filler. These are all different rooms. If I go in here and I look through the window here, I can see this. If I walk down the hall over here, I go into this room. This is my wife. This was about 3 years ago, and she wires control panels. Yeah,
that's good.
She has very good fingers. So she built the syrup expansion control panel for control of this. This was
The
5
tanks.
years ago, probably 2015, something like that. And this is me during last May. This was 1 year ago. It was actually during COVID. So you see I'm wearing a mask and I'm wearing a face shield.
Yeah,
The rain started coming down. And I know in Ethiopia, maybe you don't get a lot of rain, maybe not so much.
yeah.
Here, it's like pouring a bucket over your head. And so I got stuck in the plant and I took this picture, and you see this pallet here. We put the pallet underneath the dock so that we could jump off and not get our feet wet because it was very deep, and the pallet floated away. So it was
you cross the what kind of fabricate?
What's that?
What kind of fabricate is? It's bottling.
It is. They make water. They make juice, right? Box juice.
Okay.
So let me see. There's a picture, I think, of the box juice here. They make these juices. So the Tetra lines that I mentioned in this, let's see if there's a geographical picture. I should have put a map of the plant on it. There's not really a good map. This was what we started with. But it, they make 3 of the lines, the 3 palletizer lines make this. And in the US, this is from a company called Tetra Pak. And in the US, only some companies can have Tetra Pak franchises. They don't put lots of them in the same area that can make box juices. So in Miami, he is the co-packer for this. And yes, also makes bottled juice. So bottled juice, soda, right? He'll make soda, but it's generally the soda is his own brand. So if you've ever heard of Goliath, Goliath soda is American Beverage Depot's brand. So this is American Beverage Depot's logo. This is kind of what I started out with. And that's their brand is Goliath, but they also co-pack for Adam and Eve, which is a manufacturer that sometimes you buy box juice in Walmart or something. They'll make for them, but this is a small plant for a bottling plant. It's mostly co-packing. They make a lot of water. They do some government water. They do boxed water. I don't know if there's a box of water here, but this bottle is from their plant. So good. Aloha, that's their brand, Aloha water. So that's one of the things they make.
Also, this kind of plant when I was in internship in Cambodia. Also, bottling fabrication.
Yeah.
It's big and
it's
hard to maintain.
So there's not a lot of profit in making water. I know that. The cost of the bottle is a big part of it. But they blow the bottles here. They of course fill them. They use carbonated water for the juice beverage, for soda beverages. They don't make a lot of soda, only their own brand. I don't think they co-pack any of that. They do make sometimes boxed water. So they can make just about anything. They have basically 4 lines, 3 Tetra Pak lines and 1 PET line, which this bottle is a PET bottle, and you can fill it with, make different sizes. You can make big bottles or small bottles, and they fill them with water or soda pop or juice or whatever you want to, and then the box line. So that's everything that they do. At this point, it is pretty much the end of the webinar. So, right, I mentioned whatever else comes up. I do these every 2 weeks. The next one is June 25th. I don't know whether you guys connected through LinkedIn or through Facebook or something else, or whatever, but I do have this thing called the Automation Academy. The Facebook group is also called Automation Academy.
Okay.
Okay, Mr. Frank.
This address, right? So I try to get people to join, but honestly, no one from overseas. I've had one person from Australia join, but it's difficult because I think the payments are something is difficult, and plus it's expensive probably.
Yes,
from an
yes.
overseas standpoint. So I don't get a lot of people that join from other places. I don't have a lot of members anyway, but that's why I do this. And the next guest is Tim Wilburn, and Tim Wilburn on LinkedIn is very well known. He's a
Yes, yes.
yeah, he sells products. He builds things, right? He does a little bit of systems integration and programming. He teaches like I teach. Most of my job is teaching. That's a lot of what I do. But I have this one customer here, and that's why I'm down here. I do this maybe 5 or 6 times a year. I come down here and program and do systems integration still. The rest of the time I teach and I write books and I run this website. So that's most of what I'm doing. But that's pretty much the end of the webinar. Thanks you guys for showing up.
I'll invite people to view you. It's great.
Well, thanks. Yeah, we didn't have a lot of people show up today. Last week I had a live PLC class and we had no one show up. Another time I had a TatSoft webinar and 20 people showed up. But a lot of people look on YouTube. I have a YouTube channel. It's Automatikai, A-U-T-O, Matikai. So you can find me on YouTube pretty easy, and I always post these on YouTube.
Okay, Mr. Frank.
But yeah, it was
We
great.
shall subscribe your channel.
I always appreciate that. Like I said, I'm not making money from doing this kind of stuff, right? A webinar or I don't make much even from this website. Some people have joined and it's now starting to pay for the website, which is nice. It at least pays for the hosting and that kind of thing. But and even writing books doesn't bring in a lot of income. Integration does and teaching classes does. So clearly that's what I'll probably continue doing a lot in the future. But I appreciate you guys showing up, and we'll see you on, I think Vagif is on LinkedIn quite a bit.
Yes.
Burhan, if you are not on LinkedIn, connect with me there. If you are on LinkedIn, connect with me there. If you're not, the Facebook group, you may be from the Facebook group. So somebody must have joined from one or the other, right? Either the Facebook group or LinkedIn, and connect up with me.
I'll join.
Mr. Frank.
I'll join in LinkedIn.
All right.
Mr. Frank.
Yes.
Thanks for a great webinar, for excellent speech and excellent presentation.
Well, thank you. I'm working at it.
Really, I enjoyed it. I wish you all the success in your work in future.
Thank you very much. Yeah. Now I need to work on my Spanish. Vagif, where are you from?
From Azerbaijan.
Azerbaijan.
Yes, yes.
So you're
From
closer
Baku.
to Ethiopia than to the U.S.
Thanks a lot for a webinar.
Well, thanks, guys.
Okay.
I'm going to go ahead and stop the share. There we all are. And sign out of the webinar. And yeah, check it out on YouTube.
Okay.
We'll talk to you guys later. Thanks.
Okay, bye.